Number 10, if an operator turns the big crank at a rate of 1 revolution every 1.8 seconds, how fast is the outside edge of the smearing wheel moving in meters per second? So somebody's turning this around, and they're not turning it around 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi. It's more like 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi. So they turn it not quite one time in 2 seconds. So once every 1.8 seconds. How fast is this outside edge moving? Well, this isn't a really complicated answer because we figured out in the previous question that as you rotate the big crank one time, a point on the outside edge of the smearing wheel goes 0.13 meters. So the speed of this is, well, the distance this travels, it goes 0.13 meters per rotation of big crank. So the easiest way to do this question is just to use the formula velocity equals distance over time. So we have one event, which is somebody turning the big crank one time. So during that amount of time, the time is 1.8 seconds. The distance traveled by this during that 1.8 seconds is 0.13 meters. So we can just do the number of meters traveled by this point divided by the number of seconds it took, and we get the answer. It turns out to be 0.072 meters per second. That's probably the most straightforward method. Here's what I wrote on the solutions. Each rotation of the crank moves a point on the edge of the smearing wheel by a distance of 0.13 meters. So you have 0.13 meters per crank rotation. And there's one crank rotation per 1.8 seconds. So I've set this up so that if we multiply these together, crank rotations cancel out. There's crank rotations on the bottom, on the top, and we end up with meters per second.